My name is Stephen Trussell, and along with Stephen Brock, Hunter Massey, and Ian Haber, we are the UTDesign team that works with DRS Technologies to create a people camera, which uses a camera to observe the environment and identify how many people are in the area. We are using a DRS Tamarisk 320 thermal infrared camera to produce the images. This allows the system to run in all light environments, light and dark, as opposed to a normal camera that would need an external source of light. The leverboard streams the frames from the camera to our computer, which runs an 11-stage cascade classifier, which is developed through OpenCV. The cascade classifier uses local binary patterns to identify a person. Basically, it takes the frame, divides it into blocks of pixels, compares it to the blocks of pixels that are around it, gives it a value, and if it passes the stage, the area is moved on to the next stage, while as if the area does not match, is immediately removed and is not considered for further stage or for future stages. Currently, our cascade classifier has an image library of about 500 positive images, which are images that contain a person in it, and about 700 or so negative images that do not have any individuals in them. Currently, the cascade classifier that we are running, at the time we submitted this, we were going to use one that had 48.9% accuracy. However, it did have a false positive rate of about 9% whenever people are actually present, which means that people are being identified, like hands and shoulders and stuff, while the false positive rate is about 2% whenever there's no people present. However, we are running a cascade right now that is about 75% accurate, while having a false positive rate about 20% whenever there are people present, which means about 20% of the time it's going to pick up a shoulder or a hand. And currently, when we take account that the cascade identifies how many people are present, it averages over a course of a second to help average out the false positives. As you can see, right here, these are a couple of the test images that we use to really test the accuracy of our cascade. It correctly identified 2 people in both scenarios, and overall, it's pretty effective. We'll have it set up in the auditorium to be able to show it actually running in real time. So I guess we'll open it to any questions.
How much was the camera?
Camera was provided by DRS Technologies. It's about. We actually don't know.
You have to be able to contact DRS. Okay, I'm just curious.
Yeah.
Obviously.
We didn't actually have to pay for it. So.
What density of the crowd can this approach support? Like if you have 3 people, one person standing right between the 2 people on the left.
Right now, I think the most we've identified in a picture was about 15. But it becomes less accurate as you have more and more people in the picture, obviously. And if somebody is standing in front of another person, you're cutting off maybe half their head, it'll only count 1 person, or even 0 people.
Just depends how much overlapping there is.
We've been working in a range of like, I think, 15 feet
15
away,
feet.
15 feet away from the camera at this point in time. Yeah, 10 by 15.
Yeah. The great thing is about this technology is as the camera megapixel count increases, or pixel count increases, it would drastically increase the number of people who would be able to be correctly identified.
You obviously have this working now.
Yes.
What next? What else do you need to do?
For next semester, we will be working on having it keep track of how many people have walked through a specific area, as opposed to just counting the number of people who are in the area at the time, and also keep track of the direction of traffic.
We also hope to make this system portable, where it's not necessarily attached to the computer directly. I think we've been discussing about having the camera feed the images to a server, which then identifies the number, which then runs this cascade and then transmits that data to an outside computer, like a laptop, and a GUI runs the GUI displays how many people are present.
what's your metric for success? So what's your target? Do you have a target where you say, yes, we can identify people and we can achieve that number? Can you be more specific in terms, you mentioned a few numbers.
I would say for a final goal, I would like to have at least 90% accuracy with a very low, less than 10% false positives.
What's your definition? Accuracy on what? Number of people?
Number of people who are counted correctly in the image. So if I had an image of 10 people, I would like to at least count 9 of them.
But is that something that you're coming up, that is your wishes, or is it a requirement?
It's our wishes, I believe.
Is there any requirement from DRS?
I don't think they'd give us a requirement. They're like, hey, this is something cool, we'd like you to do it.
Any other questions? If not, I just want to thank the speaker and